Okay. All these have lymphoid follicle, which have specific B and T cell area. Okay. Rapid production of B cells. So the lymph nodes, okay, filters lymph, remove debris. Okay. What it is the lymph node will remove the debris and the pathogens from the lymph nodes. Okay. And pathogens are then sent to the lymph nodes where they are killed or eaten by macrophage. Okay, so these big ones, these little yellow things are called lymph nodes. Now it says note the number of afferent and efferent. Afferent, you guys remember, is vessels that are coming in. E for exit. Okay, efferent vessels. So on the afferent vessels, there are 3 vessels. So if you look at this in the microscope and you see 3 of these, it would be afferent. Exit has 2 vessels. Okay, remember that, please. Afferent 3, efferent has 2. Let's see. Okay. Oh, again, look up where I think I told you, look up Peyer's patches. It's around the intestines. They look like little nodule, also on the intestines. So that's the lymph nodes. Location of the lymph nodes are found everywhere, okay? Cervical, axillary region is your armpit area. Supratrochlear, okay? Inguinal, pelvic, abdominal, and thoracic area. Think of the strategy here because a lot of things can come in through these areas. Okay, and it will be very, very easily affected. So now that we saw that the spleen is a secondary lymphoid organ, okay, so if we, in the lab, we're going to see this, okay, the spleen is the largest lymphatic organ, okay, and it is right there, okay, resemble large lymph nodes but has sinuses filled with blood. Okay, so your spleen is filled with blood, okay, and not lymph. And spleen filters out the blood and not lymph fluid, okay. So again, the spleen is filled with blood. It will filters blood but not lymph nodes, okay. It contains 2 types of pulp or tissue. One of them is white pulp, one is called red pulp. Red pulp are the red blood cells, lymphocyte and macrophage. White pulp are splenic nodule with lymphocytes. So if you look at this picture, so the spleen again is the largest, one of the largest lymphatic organ. So most of the tissue around the spleen, if you look at this picture, okay, most of the tissue around on the outside of these things, they're red pulp, okay, and the white pulp, it surrounds a central arteriole. So if you see this will be surrounding an artery. So here would be an artery. So this would be the white pulp, and everything else on the outside will be red pulp, white pulp, and red pulp, okay? The red pulp, again, mostly red blood cells, and it's mixed with macrophages. Its main function is to filter blood, recycles iron. The white pulp, again, it surrounds an artery or something, okay? It's got germinating center. It looks like a lymphoid follicle, okay, that we saw earlier. Let's see where they go. It looks like this, okay, where the B cells and T cells adaptive response is mounted. Lymphoid nodules. They are dense clusters of lymphocyte. Okay, dense cluster of lymphocyte located in the respiratory and digestive tract, where things are routinely exposed to the outside pathogens. Okay, here we have here we have, of course, again, it is strategically located. Okay, one of the very, most of you have it, some of you don't, is your tonsil. Okay, it is a lymphoid nodule. Okay, it is the first line of defense. Sometimes when it swells up, of course, when you get sick, exposed to pathogens, it is swelled up and then you can't breathe, and of course, eventually you have to remove it. Okay, this is the first section of the lymphocytes, lymphoid organ. Okay, continuing with barrier defense and immune systems response. We already talked about this a little bit. Okay, you versus everything else in the world, bacteria, viruses. Innate response, okay, or non-specific. These are general defense, which do not change much. Okay, whatever that is not yours, your body will attack it. Adaptive is slower and more effective, more specific, okay, and precise targeting specific antigen, and are carried out by the lymphocyte. You guys remember, right? B cells will attack, will mature into plasma cell once it's exposed. So here are some, barrier defense. This is called barrier defense. It keeps it out, okay? Destroy things as it enter or flush it out, okay? Like your skin, your stomach with high acid, things like that, okay? Okay. Cells of the innate immune response. So innate, again, is the one that's rapid. Okay. First one would be the phagocyte. Okay. Phagocyte. Phagocytic process of eating something foreign that says enter the body. Okay. Most active phagocytes are neutrophil, dendritic cells, and monocytes, which then will become macrophages. Macrophages are very mobile. Okay, they have like an amoeba. Okay, they got little legs called pseudopods. They can swim around. Okay, they're found in the lungs, spleen, liver, bone marrow, everywhere almost. Okay, neutrophils contain granules, will enhance the response as well as engulf the pathogens. So neutrophil will also engulf them, but the granule, remember I told you, probably has some lysosome and things like that, and it will release, okay, and it will kind of destroy. Okay, natural killer cells. Okay, going back to the chart, do you guys remember where that is? A type of lymphocyte, but not specific. So it's on the opposite side. On the other side of the T cells and B cells, okay? Defends against virally infected cells by secreting cytolytic substance called a perforin, okay? Perforin, just remember, as like punches. It punches holes in the membrane and it leaks. It causes a cell to leak. And granzyme that enters through the holes and trigger apoptosis, okay? Natural killer cell may enhance inflammation. Okay, again, if something is released, you might release something called a cytokine or chemotaxins that will attract other cells to come over. 24. How do these cells recognize pathogens? So this is non-specific, and it does not involve an antigen receptor binding. Okay, a pattern of pathogen specific molecule, bacteria cell wall component, bacteria flagella, protein that interact with the pattern recognizing receptor on the cell, limit variety, so it will still recognize some of the receptors on the cell. Okay, so the limited number of receptors that are active against many pathogens, while the adaptive have larger number of different receptors that identify a particular pathogen. So the one that is non-specific, even though it is very fast, is not a lot. Okay, I mean, it's still a lot, but compared to the adaptive one, because we're always exposed to new pathogens. Okay, so the one that is adaptive, it can recognize a lot more pathogens. So let's say now you're infected with something. Okay, we saw some of these that will be released. Okay, interferon produced by the infected cells that cause uninfected cells to make the antiviral protein. Mayonnaise binding and C-reactive protein help mark bacterial cell for phagocytosis. Perforin, we just saw this. Okay, punches holes. Granzyme, again, it will cause apoptosis. Apoptosis, I forgot to tell you, it is programmed cell death. Okay, so it will cause the cell to die. Histamine will cause histamine causes inflammation. Okay, and again, it will cause dilation of the blood vessels. Okay, so more blood is going in there. The reason is because macrophages need to leak in there, start killing things. Other things will start going in there. Heparin will decrease clotting, okay, so that macrophage and other things can go in there. And defensin, it disrupts the cell membrane and metabolism of the cell. So here, let's say here's an invading pathogen. Okay, so you found a foreign antigen in your blood. Okay, then antibody will be bind to it, and then again, this is now, once activated, it is irreversible. The binding marker, okay, marking it for phagocytosis. Now other cells will start coming into to phagocytosis, and it can also act as a chemotaxis